Listen to Chariots of Fire 1600. I'm Stephen Mitchell.
I'm John Metcalf.
I'm Elizabeth Jackson.
I'm Caleb.
I'm Jared Wynn.
I'm Caleb Mitchell. I'm a team leader.
I'm Chris Iwascu. I am the other team leader. That's Elijah. That is our robot.
This year, we started by using democratic processes to make important pre-construction decisions. Then we divided into subcommittees to work on different aspects of our robot simultaneously.
Jupiter's got a robot! Oh man!
Hold on just a second.
It's just so epic! Awesome!
Look, let us tell you how it works. Okay?
Okay, what does this thing do?
Alright, check this out. It is what we call the block vacuum, and it is our method of obtaining cubes. Utilizing both spur and bevel gears, we managed to get both cubes rotating quickly in opposite directions, allowing us to suck up cubes. Now you'll notice that the exterior of one of these wheels is made out of rubber. This allows us to have a lot of grip on the plastic cubes, whereas the other one is made out of foam. This provides give so that the cube can be sucked into the mechanism at any orientation without causing it to jam. It is tilted at a slight angle so that when cubes go in, they project into our box.
This is the box. The box is made of sheet steel, and we designed it so it holds 4 blocks at a time. We also designed it so it dumps 1 block at a time. And we also made it so it does not get caught on the robot.
So you have the block in the box. Now what?
Well, that would be our lift. The box is connected to the lift via the arm, which is a C-channel that has rubber bands on it, so that has some give. So when it comes back here, it can actually fit in between these two pieces, because otherwise the length of the box would not fit, because we needed to have our mechanics and electrical pieces mounted right there. So we have our arm attached to the top of the lift. It's moved by 2 DC motors, which are connected to a rack and pinion system, and they move up and down with these two spinning in opposite directions through the same motor controller, through the same port. They're put in black and red and black, so that they go in opposite directions. And we used to have a chain lift, but we changed that to this rack and pinion because that was unreliable and had several points of failure. For instance, we had linear slides in there, and it was attached with a zip tie to this part of our robot. And so we had lots of pieces of our robot that were held up with not optimal strength. And so we redesigned it this way to make a lighter and more efficient design.
Wait, so how does this all move with that?
Well, that would be our robot's programs. This year we programmed the robot using Robot C, which we figured would give us more versatility than LabVIEW. And this year we have 2 veteran programmers, 3 rookie programmers, and 1 expert mentor programmer that helped us out to make 2 primary programs. We have our autonomous program, which we can select various strategies using a menu system on the NXT, so we only have 1 program. And our dominant strategy is to drive straight onto the bridge in the center of the playing field to block other robots, then turn and dump a block in one of the boxes for a guaranteed 40 points and 25% chance of 60 points, which we figure is even more than some other IR teams can get because they would get blocked when they're trying to get on the ring. Our other program is the teleop program, which is controlled using the joysticks on the field, and the player 1 controls the wheels and the vacuum wheels on the front, and player 2 controls the arm, the lift, and the flag spinner.
Wait. Flag spinner? What's that?
Listen here, dude. Flag spinner's powered by 2 Lego motors, and it is made out of Lego and Tetris pieces. It can effectively raise the flag to the top of the pole at an average speed of 15 seconds. Since you mentioned that, another part of our endgame is the hook. The hook is a C-channel attached to the arm. The hook goes above the pull-apart, the lift then pulls down, making the robot raise up. And that's where this custom-made C-channel comes in. If our live robot, while we're hanging, instead of hooking onto the pull-apart, they would hook onto this piece of C-channel. making it very effective, reliable, and easy double point.
So, did the robot come with instructions or something?
Unfortunately, no. And since the robot didn't come with instructions, it had to use its favorite tool, Creo Parametric. And now the team had many uses of Creo throughout the year, the first of which was in designing early prototypes to figure out what designs would and would not work. Here's a prototype of the entire robot design we used to call the backhoe, which we found a lot of points of failure in, and an old design for our vacuum wheels. The team also designed custom parts using Creo Parametric. As you can see in this picture here, it gave us exact dimensions for these custom pieces, making it a lot easier to manufacture them in real life. Custom parts include the box and the plexiglass pieces. And the team also continued to prototype throughout the year, even once the base design of the robot was done, to work on evolving and making it better and better. You can see here a picture of the evolution of our box. This was our very first Creo design, and it evolved. This was something we were going to get 3D printed, but found it more practical using Creo to use this. So Creo is very heavily used throughout the design process. We also used sub-assemblies within the program that allowed us to work on one element of the robot at a time, making it much easier to come out with the final results. I also have a picture here of how we used the sub-assemblies in Creo Parametric. See, it starts out as one piece here, and from there we made the wrist, to the arm, to the lift sub-assembly, and in the top level assembly, the robot. From there, if I want to modify a part, I need to go to the sub-assembly that part is in. For example, if I want to modify the wrist, I can go to the wrist piece, change a little bit of that without altering anything in the lift or the actual robot, messing things up. This is also good if you have multiple people working on Creo. I could be able to change the drive while someone else changes the flag spinner, and they won't be conflicting with the version of the top robot, top level assembly, since they're able to work on the sub-level assemblies. So you can see that Creo Parametric was strongly used. Essentially, we were able to create our own instructions for the robot, and that is how we have the wonderful design we do today.
Before he asks the next question, is that included in the engineering notebook?
Yes, all these pictures and more are in the back of the notebook labeled Creo.
Including older designs and newer designs that we have for super regionals.
Thank you.
The robot is just so amazing. I might even go as far as to say it's a movie. Are you able to show it to anybody else?
Oh yeah, we make sure to let ourselves be known. Before we even knew this year's challenge, we used our last year robot to demonstrate to some Boy Scouts at an event, the robot from Ring It Up, and showed them how it works. When we finally got the lowdown on what we were supposed to do for this year, we demonstrated our robot at a curriculum fair and showed many more kids there and their parents to see if they'd like to get involved, maybe even in an FLL. We are not a team of one, but 3 school groups, 2 of which are homeschool and 1 of which is public school. We had the great opportunity to have the input of an APL and a NASA engineer to give us some great pointers on our robot throughout the year. We have a website that's pretty cool, but it doesn't just tell you the typical information of this is this and that is that. But we have a blog attached to it so that you can communicate with not only those in your community, but also with those across the nation. We make sure to stay connected with other FTC teams. We've been able to have a lot of scrimmages with 3 teams and hosted a scrimmage on our field. And one of our team captains mentored an FLL team, receiving an award for his leadership skills. Last year we started out with 10 team members and 1 sponsor, but our popularity spread so much that this year we increased to 18 team members, dividing into 2 teams and 7 sponsors.
Wow. Now, I can't be the only person here with questions. Maybe some of these judges would like to ask me questions as well.
You started off by saying this year you started with a democratic process. How did that work out?
Say that question one more time.
You said instead of deciding who does what, you said democracy, right? Yeah.
We would vote on certain things, like put something on the board, vote on it, decide on what we would want. Like, do we want something to suck it? Do we want a conveyor belt? Do we want just to scoop it up. We also used Lego prototypes, cardboard prototypes, and sketches.
Some of those democratic processes are detailed in the notebook towards the beginning. There's lots of sketches of old designs that we worked on in older meetings. Even before that, we split into 2 teams. We just kind of, threw around lots of ideas.
And we also debated these ideas before we decided on them.
So what did that teach you anything, the whole process? Did you any lessons learned from the process itself?
I'd say it's a great help for the engineering process because when we move on later in life, those are the kind of processes that are going to be used, in our future engineering jobs to make big decisions on bigger projects than just, 18-inch by 18-inch robots.
You mentioned that there's 2 teams. The connect information and at what, I think a couple questions are going to come out of this. At what point did you split from 1 team to 2 teams? How much of your connect part of this is your team versus the other team, or a combination of the 2?
Could you kind of elaborate the connect part of this?
Your part that you just spoke about when you were talking about you have the mentors, you did the demonstrations, I think you said blog, all of that. Is that a combination of the 2 teams, or is that your team?
I see what you're saying. Okay. So to answer the first part, when did we split into 2 teams? Last year we were a rookie team, we had 10 members, and then we generated plenty of interest and we got to, I think, 16 altogether people interested, or 17 or 18, and then we figured it's too much for one FTC team, so we split into Chariots of Fire Black and Chariots of Fire Blue. Actually, we have a representative from Chariots of Fire Blue right back there. And for the second part of your question, I think we have...
And when did that happen? Was that like before kickoff this year?
That was before kickoff.
Okay, thank you.
Caleb, can you see if you can elaborate on the second part of the question, which was which parts of the outreach were kind of shared between 2 teams, which parts were...
As far as outreach goes, towards the beginning of the year, a lot of it was a combination of the team. When we split into teams, a lot of the members from last year's team were interspersed between the 2, so we had a lot of friends, so we were still working together almost as one unit towards the beginning. As we approached the end of the year, that seemed to sort of split off a little bit more. Like the FLL team that we mentored, that was just us doing that. Our website originally belonged to both teams, and then they split off so they each had their own website. So it started out at the beginning of the year, a combined process, and as we moved on in the year, each team did more and more outreach of their own.
Which is one feature that your robot has that sets you apart from other teams?
Well, that's a great question. Perhaps we could have Caleb answer that question.
Well, that would probably be the block vacuum, because a lot of other teams, just when they come up to get blocks, they just come and run into it and scoop it up. But we have a much more efficient design. We scoop them up. We're not allowed to turn it on and actually show you. But it's a very efficient, very fast design. It picks them up very quickly. It's lightning fast. I don't think I've seen another one at any of our competitions that's better than it.
What's your average score in competitions?
Our average score with an alliance partner is 203 point something points.
That's through all the competitions we've had so far, right?
That was just at states. I did not have information on the qualifiers.
Okay, so that was the state competition.
Since you have your robot working and you have taken part in some competitions, what is one thing that you would like to change or improve on that you feel can be improved?
Actually, let's give that one to Steven. What do you think we could improve upon?
Well, I personally think that one thing that you could improve on is potentially the vacuum, as it is currently not quite as fast as some of the other teams, and I would hope that we can get it to be a little faster so that being able to do the flag and hang would be easier than it currently is.
Due to the limit on DC motors, we've used 8 DC motors on all the other designs, and so we had to come up with a different solution for the flag spinner, so we were restricted to either servos or Lego motors. We found that the Lego motors would, a combination of 2 Lego motors would help us out the most.
And also maybe our wire management. It's kind of a mess down there. We've made it better since our other competitions, but it is one area where we could improve.
What other types of things have you learned as you've gone through qualifier states and gotten here?
Keep it simple.
Yeah, that's the classic example. Keep it simple. Found a lot of other robots had a lot of reliability issues. Especially, for example, last year with Ring It Up, plenty of robots had these really tall scissor lifts, and you could just knock them over, and they'd topple like this and that. And we tried to keep it simple with a nice compact robot that does what it needs to do fast.
I was looking at your hanging mechanism, and it had a bar to hang, but then immediately below it had another, right? So that's your hanging, right?
This is our hanging mechanism. This is for other teams to hang on to.
And we also have this space in the back here that if in a double hang you wanted to hook over another robot, this is a lot wider than a lot of hooks so we can reach over top of them.
We tried to account for both teams that grab onto the bar by the sides like this, or teams that grab onto the middle, they can grab onto here.
Been doing this all day. They can't remember which questions have been asked and which haven't. Did we talk about team dynamics? We talked about the democratic process, but what about the team dynamics? How did you work out who was going to work on what? How do you assign tasks?
Okay, I see. So typically throughout the year, when we decided, what we're going to do at a meeting, we meet twice a week for about an hour and a half in one meeting and 3 hours in another meeting. And we also sometimes schedule meetings throughout the week because we are homeschooled and we meet in the basement of the church. So we decide what we need to do, and then the team leaders, me and Caleb, we delegate tasks to various people. Most often we delegate the tasks that somebody's been working on. For example, if we're making an improvement to the flag spinner, we would hand it to Aiden Karmazinski, who unfortunately couldn't be with us today. He did a lot of the flag spinner tasks. So they would work on that throughout the meeting, whilst other people would work on other parts throughout the meeting. And so we divide into essentially subgroups, teams, as the meeting began, to work efficiently on different parts of the robot.
Let's say tomorrow, God forbid, your flag spinner has issues. Who will fix them?
That would likely be a congregation of the whole team would help fix that. Particularly either Aiden himself because he works on the flag spinner, or the team leaders because we have a pretty good knowledge of all the components on the robot, so that if anything breaks, we can go out and fix that. So we try and make sure that everybody on the team knows how every component on the robot works so that they all can fix it. So nobody's left in the black about any parts of it.
Also with each individual part, when you start a project, no individual person is working on it alone. You at least have 2 or 3 people working on it with them, so they're not the only person who can make upgrades or changes on it. So actually, I was the one who actually built this. Caleb designed it. He made instructions for it. I built it, and Aiden upgraded it.
We actually have those instructions. They're all done out in Creo, multiple pages for the flag spinner in the back middle.
Sounds like that's the buzzer. Is there anything real quick that you want us to know that you haven't had a chance to tell us yet?
Let's start with, just real quick, what are we most proud of on our robot, Steven, over there?
Well, on the robot, I enjoy every component, and there's really no answer to that. That's more personal preference. So
However, I think in general we're proud of our outreach. Being able to get other people involved is a beautiful thing. We promote first, we love it, and we are also proud on the robot itself of our theme song.
Yep. And since we're the Chariots of Fire, we'd like to play that music for you as we exit, if we're allowed to exit now. So,
good luck.
All right.
Good job.
Thank you so much for your time. We know it's a long day.
Thank you.
So thank you so much for judging, and
Good luck for
hope to see you tomorrow.
Good luck in the game field.